So welcome to this first lecture on the course on linear statistical models. So in this lecture, I will just do some very basic things about the programming software called R that we will use in the course. You may all be familiar, but I'll just for the people who have not installed R or used R, I will just do a quick review of R in the first lecture. So R means many things to many people. It's the key aspects of it. It's an open source software. It runs on all platforms, Linux, Windows, and Mac as well. And it's free. You can download it for free on the internet. And it's available at this R project page right here. And so we will use it in many ways. We will use it as a powerful calculator whenever we have data sets and we want to understand many computations. We'll also use R's graphics tools. It's called, so I'll just call it, for lack of a better word, visualization tools in R. And of course, since it's a linear models class, I will use many of the statistical packages in R to perform analysis. So available in R. To do statistical analysis. So that's the main mission with which we will work with R. So today I'll just do some very simple things. So just a brief history of R. R was started with a language called S in the late 80s at AT&T Labs. Then the R project started by two people, Robert Gentleman and Ross Ihaka in New Zealand. So this paper that they wrote in '95 outlines their vision of R and how R is to be developed and so on, as software. So which I will not require in this class, but I would encourage you to read it if you have an interest in software. And now, of course, R has grown tremendously, and it's a collaborative project with many contributors. Any of us can contribute packages to R, and it's maintained by an R code development team. To download R, you can just go to this Cloud R project and then download R. It's available in for all formats. And I also I'll encourage you to download R Studio as well, which is what we will use throughout the class to do programming and run codes on it. And please download both R and R Studio onto your desktop. So you download R. So R version is, I think the version is 4.0 plus is what I will use. And then I'll also encourage you to download R Studio as well. So there's an interface that will help you work with R. So the first thing today I would like to do is use R as a calculator. So I would like to try these following commands on R. So one is so 9 by 44. The slash is a division operator. And the star is a multiplication operator. And the last one is the logarithm is just the logarithm function, that's natural logarithm function. So that's inbuilt inside R. So let's try and do this, and let's try and see how R responds. So let's go to R Studio. So I'll go to R Studio in a second. So go here. So here I type. If you look at the top, the first thing I did was I went and opened up. I did this before you guys came. The new file, and I went to R script. So that's how I opened this file. So it'll come like this. Let's say I save it as first thing. Let's say I give it a new name. So let's say I save it as, let's say, first class. .r. So it should save. I don't know why it's not saving in my machine. I saved as first class .r right here, right? That's the name of the class. So the first thing I'll do is, so the top part is, if you look at there are two windows here, the top and the bottom in R Studios. We'll come to these three on this side a little later in the class. So first thing I want to use a calculator, right? So I do 9. I have 9 by 44. This is what I had, right? So if I do this, I have that right there. So now to run it, I can either go here and then go to the run console right here and then just say click run, right? It should run it. So when it runs, it'll show at the bottom the exact calculation. So it shows 9 by 44 is 0.2055. So I'll come to what 1 is in a second. The next thing I did was I did 0.6 times 0.4 plus 0.3 times 0.6. So let's try to do that. So let's do 0.6. So sorry, let me go here. 0.6 times 0.4 plus 0.3 times 0.6. So I type that in. So that comes out like this. And then if you run it again, click on the run button, it'll show up below. In the below console right here, the computation will show up. So it says 0.42, which is exactly what we had here, right? The last one was this log of 0.6 thing plus 0.3 times 0.6. So let's try and do that. So I have log of 0.6 star 0.4 plus 0.3 star 0.6, right? And I think I put an extra bracket there. I'll remove the extra bracket. It doesn't matter, but I'll just remove it. Remove this, and I come this side. Come down. So again, it's giving me an error there because I have only one bracket. So I'll go back here. There's some mistake in my machine. I know it's freezing. Go here. It's giving me an unbatched bracket. Let me come here. I delete this. Then I go and run this thing. So run it. It'll again run log in the console below. You can check. It'll run log, and it gives you an answer minus 0.8. So this is a simple way of using R as a calculator. So one thing you could do is, since you're taking notes in the class, you can keep comments in the R code itself. So what you can do is, to do comments, you go here to the previous line, and then if you put a number sign, then R will not execute that line. So you can just say slash is division operator. Oops, man, spelling mistake. And my computer is very slow today. I'm not sure why. And so on and so forth. You can give everybody a comment like this. Like so for yourself, when you take notes, you can give notes like to yourself, and then R will not execute that comment. And here you can come and say again, if you want the next line, you can again say star means multiplication. And so on and so forth. And then you can also keep in the next line, you can go and say, you can say log means natural log function inbuilt inside R. Very good. That's it. So now let's go back to the notes again. So let me go back to the notes. So this is exactly what I got, right? I got this 0.204, 0.42, and minus 0.86. So then, like I pointed out, there is this one at the beginning of everything. That's for a good reason. See, R stores everything as a vector, and 1 represents the position of the element in that vector. Okay, so I mean there's only one element in the vector, so it's giving you 0.205 as a so this is one thing you must keep in mind, that R stores everything as a vector. So you should keep that in mind. Any computation you do also, it will be stored as a vector, and this 1 indicates the position. Okay, that's all that's to it. So this we have seen now. So next thing we'll do is I'll try and just do a simple computation for you. So let's say I want to enter scores of 10 students. So here are the 10 students. So let's say these are scores out of in a test. So the scores in a test. Scores from a class test, let's say. And these are the scores. That is 40, 39, 15, 6, 18, 22, 30, 21, 15, 23 scores. So now what I want to do is I have to, if I want to enter the scores in R, I have to use the concatenate command. It's called C command. So I have to use that. That's the first thing I have to use. And then what I do is I give it when I say equality and I give it a name. So the name I've given to this whole thing is scores in DS. So that's the vector's name. So scores in DS is the name of the vector. So DS is S is capital, is the name name of the vector that I've given, right? Okay, so let's try and do this. Let's go to this. So let's remember the numbers. Let's come back to R Studio. So I come here. So I come here. So the second part is I do Control Z, I guess. I'm not sure. What happened? So yeah, let's go here. So let's see. So I called it scores in DS equal to C of, and then I go back here and the scores are what? 40, 39, 15. So 40, 39, 15, 6, 18. Then I have 22, 30, 21, 22, 30, 21, and I have 15 and 23. 15 and 23. Okay. So those scores I have of the thing, right? So then I go here and I run the command. So if I go here and I go here, run again, I go run. So it'll run the command. So in the bottom you will see that it'll stores there. So now I can call it. So how do I call it? So I come to the next line. I just say scores in DS. If I write the whole variable name, right? It'll also prompt you with that thing. And if I run this whole thing, it'll give the entire list of scores that I have, right? It gives the first position is 40, and then if you look at the bottom right here, the first position is 40, and then 39, 18, so on and so forth. That's how 15, 6, 18. That's how it goes. Very good. So the other thing I can do is, since I didn't explain to you what the C command does, I could even come here and say, if I want to understand about the help menu for C, so what I do is I come here to the console below and I type question mark and I do C this way, right? It'll come up. So if I do this and I press enter, on the right hand side here, it should give me the help menu for this thing. Let's see if it comes. It comes. See, so C is just a combined values into a vector or a list. So it says here the generic function which combines its arguments and so on and so forth. So it gives you an exactly how does C work, right? So I've used C very simply, and then it gives various examples of C as well, which you can play with later on. Okay. So here, what I want to do, I want to go back to my calculation right here. So I have stored this vector. So next thing I want to do is, let's say I want to do some computations with it. So like I've explained to you, the assignment operator is the is equal to, right? That's what it's doing here, right? And I've assigned all values of the scores in the class to a variable. The variable is called scores in DS. And if I want to display it, I just type in the variable name. It'll display all the variables that I've stored in it. Okay, and this is how I've used the C command, right? Very good. So now I can do many computations with it. So one is, let's say I want to compute, let's do a simple thing. Let's say I want to compute the average score in the class, let's say. Right. So one way to do it is I can do the mean myself. I just do 40 plus 30 like I've done the first line. So let's just do that. Let's do that. So I go here and go to this top thing right here, and then I compute it, right? So let's see. So let's say mean score is equal to, let's say I call it mean score this time, right? Is equal to, so what I call it? I call mean computation. Let me go ahead. Is equal to, right? So I do this. So then what I do, I have to compute the mean, right? So I do 40 plus 39 plus 15 plus 6 plus 18 plus 22 plus 30 plus 21 plus 15 plus 23, right? This is what I have. That's a sum, right? But I want to compute the mean, so I put a bracket here. I go here, I put another bracket there. I come on this side and I put a slash, and I have 10 people, so I divide by 10, right? So that's the answer, right? That's the mean computation. So I've assigned the variable mean computation, the name mean computation to the sum, right? So I run again. So it's run and kept it. It should have kept it there. Right? Let's see if it comes below. It'll come, right? So if I want to call it, I just type in mean computation. If I do this and I go run it, it'll show me the exact value of it. Let's see if it comes. It comes 22 point, which is exactly what I had at 22 point. Now R also has, so you can do it in two ways. So one way is one can do the computation directly. The other way is use inbuilt function in R, right? So this you will find regularly throughout the class. You can write your own code, or you can use an inbuilt function in R. Both have certain advantages and disadvantages. But for efficiency wise, it's always good to use the inbuilt function. So the inbuilt function here is the mean function. So that's already inbuilt in R to compute the mean of a variable. So let's go back here. So what you can go back here, you can type in here, you can say mean from, so what did I call it? I just call it mean inbuilt, right? So let me call it mean inbuilt. So mean, so let me go here. Mean inbuilt is equal to mean of, I put the word mean of, and inside the variable I'll put is scores in DS, right? So scores in DS, right? So it'll again give you a computation autofill. You can use that or you can type it yourself. And once you do this, you go type run again. It'll compute the thing below, and then now you can again say mean inbuilt. And then if you go run it, should give the same answer. Let's see if it does that. So let's see if it does that. I ran it. It's 22.9, same answer. So both our way of doing it and ours inbuilt. So let me write this comment down in line 15. So let's say above is direct computation by us, and below is using the inbuilt function in R. Very good. That's the idea. So now this is something that you'll use repeatedly in this class. You can try, and it's a simple example. You can also try to do, if you want a simple thing, you can do a simple exercise. You can try is so in both ways. One is compute variance, and then next thing you can do is you can try to find an inbuilt function. So try to find out and check it out. Very good. So now the other thing R does quite quickly is that you can change. Let's say I'm an instructor. I'm in this class and I've done these scores, and suddenly I find out that one person's score is wrong. Let's say the fourth student's score was not 6 but 16, right? So then I can go and change change entries in a clever way. So I can change entries using the index of the vector. Okay. So what I'll do is I will first create a copy, and once I create a copy, in the copy I will change the score. Okay. Let's see. So now let's go here. So the first thing I do is I come here. So I say scores in DS2. I create a copy. Okay, and that's the same as scores in DS. Okay, that's the first thing I do. I create a copy. Right. Okay, then I go and run it. Let me run this. So create the exact thing. Here's that. Then here what I do is, like, I want to change the student scores, the fourth student score. So I go scores in DS, and I do at the fourth element, and I make it equal to 16, from 6 to 16, right? So that's all I do. I put 16 right here. So I've just changed the fourth student score, right? So then I go run it. So now let's just check if the scores actually change. So if I do scores in DS and I do scores in DS2, let's check both them. So I have to be careful. I go here. I do this, and I have two things. So let me go here. Let me go here first. So I run this. It'll come below. So you notice that the fourth student score is 6. I run scores DS2, where I've actually changed it. It should come as, oh, it's not coming. Maybe I made a mistake. I put a, let me go again. I made a small mistake. So it's like a small s. So 16, right? That's exactly what it is. So that's exactly what happened, right? So change the thing. Then also you can do is you can also call specific elements of the string. So you can also isolate or /call specific elements of the vector by their positions, right? So let's say I want to know the scores of the first, third, and fifth student. So I go back here. So I just do the same thing like I did here, right? So here, so what have I done here in the above? I've changed the score of the fourth student from 6 to 16, right? Okay, there are two spelling mistakes. Let me just correct them both out. Let me go here. Here it should be above, and here I should just say student. Good. Now, what I want to do is I want to call. So I want to call a specific thing. So what I do is I go scores in DS2, and I do, let's say, and I want to call a specific, let's say a bunch of, so I want to call the first student, third student, fifth student, right? I think I put a bracketed mistake. Very good. I go across and I just go run this thing. It should give me the exact the 1, 3 and 5. Let's see if it comes correctly. So it comes correctly. 40, 39, 15, 40, 15 and 18 are the first, third and fifth student score. Let's see. Very good. Now, the other thing also I can do is I can go and grab scores of students which are equal to one number or less than equal to number. So you can also select or find entries that either match a criteria. That match a criteria. So here I did one thing. I said I wanted to find the scores that are equal to 30. Then I get 7. The other one I said less than equal to 20. It gives me all the scores that are less than equal to 20. Let's try that. So let's go here. So here is choosing elements based on position. Because this is doing. So now let me go here. Here put n here. And the next one I do is like I want to find which of scores in DS2 is less than or equal to 30. Let's say equal to 30. So I have to use the qualification as 2 equal to assign equal to, right? Let's just run this thing. Let's see if it comes correctly. It should come as let's see if it comes. It's a 7. That's exactly what I had here. So here, just notice that match is just so equal to is for equality, and less than equal to is for less than equality. So I can do the same thing here. So let me just go and do the same thing. So it doesn't. Let's see if it can copy it. No, copy the whole thing. I don't want to do that. Yeah, let me Control X. Come down here. Let me type in which of scores in DS2 is less than equal to 20. So I should come here, and then I think I left the S out. So I should put an S here. Come here again, and I just run it. Right? Then it should give me the thing. 1, 3, 4, 5, and 9. That's exactly what I had. The third student, fourth student, fifth student, and ninth student have less than 20. Very good. Now let's just try to do a thing in which we want to create a sequence of vectors equally spaced. Right. So here, let me write this down. So you want to create a sequence of vectors equally spaced. So sequence of vectors which are equally spaced. Okay, so that's one. So the first thing is as x equal to 1 is to 100 creates vectors elements 1 through 100, and they're exactly 1 apart. So that's exactly what it does. So it creates 100 elements. So x is equal to 1 is to 100. It creates 100 points. And then let's run it. If you run it, it'll give you x below. Let's see what x is, right? And then if I type in x and I run x, I should get exactly what I get. If you look at the below part of the screen, I'll give you all the 100 points once. Okay. So this is like creates equally spaced points between 1 and 100. Okay. Let me just my English is all, my typing is all odd. Let me put the A there and put the T here. Put the T there and then put an L here. Okay, L I got correct, the T I got wrong. I put a T next to the S. Very cool. And then it creates the extra S here. We go there and then let's delete the T. This machine is so slow. Very good. You can also use the sequence command, which I'll write down in a second. So you can say x equal to sequence of 1, 100, and then you'd use the word by after that. So you can say by equal to, let's say, now we want 100 equally spaced point. I just say 1 by 100. Okay. Oh, I made a mistake. Let me just come back in a second. Let me call this XS. Yes, and this is 1 by 100. 100. Let's try that. Let's see if it works. Let's run it. So this will give you again the same way. Let's see if it works. It does. Let's type XS and let's run it again. It'll give the same as X, right? So there's no problem. But so it's giving you 100 points between 100. I don't know what's it doing now. Let me see something else it's doing. Sorry about that. Yeah, it's giving you points spaced by 1 over 100. So for example, if you look at the top, so it split the interval into 1 by 100 into points that are distance 1 by 100 apart. That's what this is doing. So it's giving you an extra as much division as you want. So if you want to imitate x, you just say by equal to 1. That's all you do. So let's do the old one. X old, just a sequence 1, 100, and if you say by equal to 1, it should give you the old one back. That is just a distance 1 apart. So let's do run, and then let's do x old. That should match x. So it'll give you exactly the same thing before. Go back here. So you can also use the colon command, or you can use the sequence command, and by to specify a distance apart, each element how distance apart. The next one is you can go and pluck elements out from x again by various criteria. So here I have plucked things that said that x is less than 10 or x is above 90. I'll let you figure it out yourself. You can try it yourself. So you can say, you can call x of, and you can specify any criteria that you want, and the R will output that particular criteria. Okay. That's broadly the the class on just playing with R as a calculator and doing some symbolic computations with it and writing out vectors and plugging things in vectors and so on and so forth. Okay, thank you.